Okay, guys, section 1.4. We've already dealt with linear equations. Now I want to talk about quadratic equations in one variable. So, the standard form for a quadratic equation that we usually try to get into is this: ax squared plus bx plus c equal to 0. So essentially, we're writing it in descending order of its powers, and we want it all equal to 0. That's usually going to make things the easiest for us. Little fact here, quadratic equations are second degree equations. What this means is they can generally have no solutions, one solution, or two solutions. That's what you should expect. The zero factor property. So what I'm going to do here, and I'm pretty sure you guys have seen this before, I'm going to show you a few different strategies for solving these quadratic equations. Generally, you can use whatever strategy you want, although when we do get to completing the square, I am going to want you to know how to do that. Okay? You will have a question like that on the test, but I'll remind you when the time comes. But for the first strategy, we want to use the zero factor property. Essentially, this is to solve by factoring. It tells us that if a and b are complex numbers, which usually we're going to be dealing with real numbers, so only real parts, with a times b equal to 0, then one of them has to be 0, or both could be 0. So that's the first fact I'm going to need. What that's going to tell us is we're going to take this when we have it in this form, factor it, and then use the zero factor property. So let's start with a. For a, I have x squared plus 2x minus 8 is equal to 0. So I'm looking at this, I'm going to think factoring. Hopefully this is fairly easy for you to factor. I'm seeing it sort of as a reverse FOIL. I need things that multiply to -8 and add to 2. So I think plus 4 and minus 2 is going to work for us. Now here's the thing. Think of this as your A and think of this as your B. They're being multiplied. So if when they multiply they equal to 0, then I know either the first part has to be equal to 0 or the second part has to be equal to 0. So either we get -4 or 2, and then we can write it as a solution set. And of course we do know how to check those. We can plug them back in, okay? So you can see why it's important that it's equal to 0, because if this was equal to 1, then we couldn't say this, right? Because then this could be 1 and 1, could be 1/2 and 2, 1/4 and 4. That's why we like 0 on the other side in a quadratic equation. Looking at this one, we have x squared plus 1 equals -2x. Notice that's not in the form where everything is equal to 0. So what I'm going to do is I'm going to move the 2x over. So now I have x squared plus 2x plus 1 is equal to 0. I'll try the same strategy. I'll factor this guy. And what you'll notice is this thing factors, and its factors are the same. So from both of them, I'm getting x plus 1 equals 0 or x equals -1. That's my only solution. So here we had two solutions. Here we had only one. Okay? So that means my solution set is -1. One other thing I just thought of, just as I'm making this video actually, is when we said we can generally have 0, 1, or 2 solutions, that's specifically for real solutions, okay? Because we can have complex solutions, but we do know how to deal with complex numbers now. Let's look here at C. 4x squared minus 64 equals 0. This one's a little different. We don't have that middle bx term, okay? So what we're going to have to do here is first let's see if we can pull out a GCF. I notice I can pull out a 4. Then I got x squared minus 16. Okay, well that's good. It's still not fully factored though. If you notice, this is what we call a difference of squares, so we know how that factors as an x plus 2 and an x minus 2. So we're right there now. Okay, so now I got three things being multiplied, like an a, b, and c. So either 4 is equal to 0, which we know will never happen, or x plus 2 equals 0, or x minus 2 equals 0. Looks like we got -2 and 2. So I'll go ahead and I'll write this as a nice solution set. So we're seeing factoring as our friend. It's really helping us. And now I got one that's a little more complicated. This one right here, same strategy. Get everything on one side, first of all. So I got negative 6x squared plus 7x plus 10 equals 0. Now, if I'm going to solve this by factoring, I don't like that negative 6 out front. So I can at least get rid of the negative by multiplying both sides of the equation by a negative 1. Just like so. That's going to flip all these signs. And that's still equal to 0 now. So from here, well, how do I factor this? You can guess and check. You can try 2x and 3x or x and 6x. But I like the AC method from factoring. Okay, and if you want any more videos on how to do this, please let me know. But what I'm going to do is I'm going to split this middle term. Some people call this the box method. So I'm going to split negative 7x between these. Well, then the question becomes, well, how do I find that negative 7x? I'm going to take these two. They multiply to negative 60, and I'm going to try to find two of these that multiply to negative 60 and add to negative 7, two factors of negative 60. So I got to think about, okay, well, what's going to work? Okay, so if I think about it, I think a negative 12 and a 5 should end up working. So that's what I'm going to put in the boxes. I'm going to put negative 12 here and a 5 right here. So now I have 6x squared minus 12x. I'm going to group those up, plus 5x minus 10, and I'll group those up. Hopefully this method of factoring looks familiar. Maybe you do it a slightly different way, and that's fine. So from here, this is a factoring by grouping problem. I'll pull out a 6x, so I get x minus 2. Here I'll pull out a 5, so I get another x minus 2. So notice that my GCF I can pull out is x minus 2. That means I now have x minus 2 times 6x plus 5 is equal to 0. This thing's factored. If you're not sure if you factored it right, multiply it out, make sure it's what you started with. Okay? So from this, I think I'm going to have to go to the other side here. I have x minus 2 times 6x plus 5 equals 0. So two possibilities. Either x minus 2 equals 0 or 6x plus 5 equals 0. So I got 2 and I got negative 5 over 6. And I'll write my solution set like so. Okay, so there's a few examples of using this zero factor property. Like I said, you got to practice the problems in the book to see some of, maybe there's some other problems with different nuances that are tough, and ask any questions you have. All right, there's the first video, guys.